Hello, I'm Zach Jensen, and I'm going to be doing a statistics problem that we did over the summer. Today we will be talking about combinations. Combinations of items or arrangements in when different sequences of the same items are not counted separately. And this applies when we're talking about the combinations rule. Combination rules states that numbers of different combinations when n different items are available, but only r of them are selected without replacement. The order does not matter with combination rule. N is equal to the total number there is to work with, like 70 or 25. R is the amount of numbers chosen without replacement. That'd be like stating that you want 70 of something, but you're only allowed to choose 6. Without displacement means that selections are dependent events, and dependent events affect the outcomes of the next outcome. And there, in it, is the combination rule. And along with combination rule, we get this nifty little equation right here. NCR equals n exclamation point divided by n minus r exclamation point r exclamation point. Now the numbers on the sides of the C, or the letters on the sides of the C, the n and the r, they don't really matter on this side of the equation, they only matter on the right side of the equation. So now we're going to be doing a problem. This is going to be a combinations rule equation. The Mega Millions lottery game in California has a player choose 5 numbers between 1 and 70, and 1 number between 1 and 25. In order to win the highest jackpot, the player must choose the 5 correct numbers between 1 through 70, and the mega number between 1 through 25. What is the probability of a person winning the highest jackpot offered by Mega Millions? Now there are several different ways we can do this. We can do this both through technology, and we can do this both on paper. So the way that you would do this on paper is you would write, you can do this if you want, but I'm just doing it for the sake of the example, NCR is equal to n exclamation point divided by n minus r parentheses exclamation point r exclamation point. So there's our equation, and I will input the numbers into this equation. So for our n, we have 70 and 25. Because we have to deal with 2 different equations, we will be doing 2 of these equations in one problem. So we have 70 over 70, right there, 25, 25. And then what we will do is we will take the numbers we have to work with, our r, which is 5 and 1, and we would put 5 with 70, because 5 specifically states between 70. Minus 5, exclamation point, 5, exclamation point, and 1, because it specifically states with 1, 1, parentheses, exclamation point, 1, exclamation point. And there is our full equation. Now, the way we can do this through the calculator, unless you wanted to do it by hand, is this. So what you do is you take your calculator and you put in the first number, which is 70, which is the number you're going to use. So 7, 0. Then you go to math, and you go all the way over to probability and all the way down to NCR. Hit enter, and that's what you get. Then you input your number, which is 5, into the calculator and hit enter. And that will give you the total number of probabilities that you're going to have when dealing with this particular set of numbers, which is 12,103,014. So let's go ahead and put that down on our paper. 12,103,014. So that is the probability of picking the correct 5 numbers between 1 and 70 in our Mega Millions lottery game. Now, the way we can do this on paper without having to use the calculator is this. So, because these numbers right here have the exclamation points, people wonder what that means. The exclamation point means that you're drawing out the number until it hits a 1 or it hits another exclamation point that is of the same number. So what we will do is we will do 70, 69, 68, 67, 66, 65. Now 70 minus 5 is 65, so automatically our parenthesis number now has a number that is 65 exclamation point. And this is how it would look if you were to draw it out to where it was supposed to be. Because 65 and 65 are the same, we can cross that out and our equation therefore stops there. All you would have to do is multiply each of these numbers to itself, and then you have to draw out the 5. So it would be 70 over 60, 70 times 69 times 68 times 67 times 66 over 5 times 4 times 3 times 2 times 1. And therefore, this is what your final equation should look like if you were to do it on paper. And then if you didn't know how to do the NCR equation in the calculator, but you knew how to do it on hand, you could just manually input the numbers into the calculator. So you could do 70, 69, 68, and 67, and so on until you get to your final number, which would be 66. And then do the same thing for your numbers on the bottom. So we will input the numbers into the calculator, and we will divide that by 5 times 4 times 3 times 2 times 1, parentheses, so that way it doesn't mess up your number. And as you can see, the same number we got, 12,103,114, same as the number on this side. Now that was the more complicated version. The next one we're going to do is actually very easy because it's very simple. So the next number we have to choose from is between 1 and 25, and we have 1. And so because we have 1 and 25, exclamation point, and then 25 minus 1, exclamation point, 1 exclamation point. Everybody knows that simple mathematics will state that 25 minus 1 would be 24. So as soon as we draw out 25, we immediately hit 24, exclamation point, and therefore those would be crossed out. Boom, boom. So therefore, and because this is a 1 and it would be drawn out to a 1 only, it would remain a 1. So therefore, your equation for this would be 25 over 1, making your probability of guessing that number correctly 25. So we have 12,103,014 and 25. Now, you're wondering, well, we have these two different numbers, but they have to be put together. Yes, you would have to multiply these numbers together in order to get the actual amount that you're going to need. So, if you multiply 12,103,014 times 25, you would get 302,575,350. That means that your probability is going to be 1 over 302,575,350. While not impossible, it is extremely unlikely that you will get the Mega Millions lottery number correct and win their highest jackpot. This is a very simple calculation problem. You just have to know where to put the numbers. And as I stated, any number that you have to choose between, like 70 or 25, those will be your n's, or the numbers that you have to choose from, and your r's will always be what numbers you are choosing from. So where these are the ones you're choosing from, you have to choose between 5 and 1. So therefore, those are what your R and N values are. I'm Zach Jensen. Thank you for watching. This is statistics that we did over the summer.